Yeah. Coming to the oil circuit breakers. Before going to discuss about the oil breakers, circuit breakers, let us see the overall view of these various breakers. So if you see here, the circuit breakers, different breakers, AC breakers, they are classified into DC circuit breakers. Here DC circuit breakers divided into HVDC circuit breakers. These you are going to discuss in the final year. Coming to the AC circuit breakers, high voltage side circuit breaker and low voltage side circuit breakers. So we are discussing about the high voltage side circuit breakers because low voltage side means it is miniature circuit breaker. That anyway I have given that information at the last of the SF6 breaker. Okay, this gap is I'm admitting some people. Yeah. So high voltage circuit breaker is divided into oil circuit breaker, oil less circuit breaker. In the oil circuit breaker, you can see bulk oil, low oil, that is minimum oil, air brake circuit breaker. Okay. So coming to the oil circuit, oil less circuit breakers, we can see oil less circuit breakers. There are three types. That is air circuit breakers. In that air, there are two types: air brake, air blast. SF6 vacuum circuit breakers. This is the total classification of the various breakers in the high voltage switch gear. So next, coming to this classification, you can also see the classification like this: circuit breaker, oil circuit breaker, vacuum, SF6 and air. Oil is divided into low, minimum oil, bulk oil. Again, bulk oil is divided into plain brake as well as ARC control circuit breaker. That is forced blast, self blast, plain explosion type, cross jet, self compensated type. Here in the air circuit breaker, it is air blast, plain air circuit breakers. In the air blast, there are three types: axial blast, cross blast, and radial type. Okay. So coming to oil circuit breakers, you can see these pictures. If you see outside in the switchyard, you can identify what is oil circuit breaker. If anything is like this, is the dead tank type, live tank. So this is the view of various breakers in the switchyard. You can recognize by observing this. So what is the principle behind these oil breakers? Here we will use mineral oil, which has better insulating properties than air. So steam has immersed an ordinary knife switch in the oil and investigated the braking capacity. And compared to normal air, if you immerse the knife switch and open the knife switch, what is the braking capacity observed? Definitely compared to air, it has better insulating property and better arc punching property. Reliability, simplicity of construction, these are the better advantages of OCB. So these are the disadvantages. Mainly thing is oil, inflammable, cause fire hazards, possibility of its forming explosive mixed with air, and there are sludge formation, carbon particles due to heating. So these are the disadvantages. These contacts are usually operated by pull rods, rotating insulators, etc. Solenoid, pneumatic mechanism, the opening and closing of the contacts by this. So the main thing we are using in the oil breakers is, okay. So in OCB, some insulating oil that is called transformer oil, which is mineral oil, is hydro treated light naphthenic distillate, the chemical name. that is used as arc quenching medium. So contacts are opened under the oil, or if the arc is struck, then already you have seen in the Buchholz relay, when the oil decomposes, it produces hydrogen gas. 70% of the hydrogen gas will be there when the oil dissociates. So that is the main quenching medium. So which is a lightweight. Hydrogen gas occupies a volume of 1000 times that of the oil decomposed. So 1000 times the hydrogen gas production will be there than the oil decomposed. So oil is pushed away down and hydrogen gas move upwards and occupy the entire place of the arc region, which is between the contacts. So that is the principle behind oil circuit breakers. So they were majorly used in before 1960s for all types of applications. So here we can see firstly what happens. Hydrogen gas has high heat conductivity, cools the arc, thus aiding the deionization between the contacts. Secondly, gas set up turbulence so that this oil will be forced. Okay. So secondly, what happens? So here the gas set up turbulence in the oil and force it is into space between the contacts, thus eliminating the arcing products. Finally, the arc will be extinguished. So these are the two steps. One is removal of the heat, and the other one is occupying the entire place so that arc quenching process will be successfully completed. So oil acts as both arc quenching medium as well as insulation. So oil breakers divided into plain break, controlled break, minimum oil, circuit breakers. This plain break and control break is bulk oil breakers. They are dead tank type. You can see here. These two are dead tank type, means the tank is at earth potential. Tank is at earth potential. Bulk oil means there are more amount of oil required. So if you observe here, this is the minimum oil circuit breaker, where the amount of the oil required is less, almost 10% or 15% of the oil required here. Okay. Okay. Here you can see oil breaker divided into bulk oil breakers as well as minimum oil circuit breakers. This is called live tank construction. Live tank means the tank is kept above the ground with some insulated structure. So up to 12 kilovolts indoor type is used. 36 kV, 72 kV, 145 kV outdoor type, and 245 kV it needs modular construction. That means the different modules will be there that you are going to discuss. That is T-shaped or Y-shaped construction will be there. 2 interrupters are required. So you see, first thing is bulk oil breakers. You can see more amount of oil is required. Before 1960, up to 725 kV it is used. However, popularity of the breaker is decreased because more amount of oil is required. It needs more installation. These breakers have 3 separate tanks for 725 kV because the voltage is divided in series. So for 36 kV and below, single tank construction is enough, which is popular. Single tank construction, phase barriers are provided between the phases. Between the phases, phase barriers will be there. This type of breaker is used for indoor metal clad. About 12 kV, it is usually outdoor type. So dielectric oil is used in these breakers. In this type of breakers, more amount of oil is required. Therefore, it is now obsolete. That means it is not in popular use. So this one you can see plain break oil circuit breaker, where the contacts are separated like this by this rod. The rod is pulled down, the contacts are separated, arc is drawn between them. As I said, first the gas produced, the H2 gas will remove the arc. That means we'll reduce the diameter. Next, this entire region is filled with this oil. There is no separate mechanism. Simply the rod pulled down and this part, the arc is quenched. There is no separate mechanism in this. So in the plain way, this way also you can see when the rod is pulled upwards, these contacts will be closed. When the rod is pulled downward, contacts are open. You can see this is a fixed contact, this is a moving contact, this is a second break. So the oil in this. So we can see some portion is left open for expansion of this oil or gases production to reach the top, and this is air cushion. So plain brake oil circuit breaker is earliest type of the oil circuit breakers. As I said, these are the various things: fixed contact, moving contact, air cushion is provided on the top to allow for the reception of the arc goes without generation of unsafe pressure. If it is not provided, what happens? Pressure in the tank will be increased. For that, we need some air cushion is required. It is called a double brake because at the same time you can open two contacts here, fixed and moving contacts. So here, what is the process that is involved? Hydrogen gas bubbles produced. Gas, whatever the gas produced, that sets up turbulence. That means some movement in that, and as the arc lengthens, and that means as the contact moves, the arc path increases and some gap will be increased. Intentionally, how to increase the gap so that arc will be lengthened, so arc diameter will be resistance is increased, arc path resistance, arc can be quickly cleared. So that is the process involved, that much. What are the disadvantages? No special control is available, only lengthening length of the contacts, length between the contacts will be to be increased. So successful interruption, for successful interruption, less arc length is necessary. So these breakers have long and inconsistent arcing wave. These breakers do not permit high speed interruption because there is no special mechanism, only how to open, oil will be decomposed, hydrogen gas will be produced. This is the only regular procedure. There is no separate mechanism for quick arc extinguishing. So coming to this same breaker, here there is some development. Compared to the previous picture, here you can see one control device. This is called arc control device, in which so a pressure can be created. Whatever the gas produced in this narrow region, high pressure can be created such that arc extinguishing will be quick. So this is the new development in the bulk oil circuit breakers. Takes place in the steel tanks. Gas is formed due to heat of the arc expand and set turbulence. So to assist the arc extinction process, arc control devices are fitted. So this is the arc control device, which is a halo shaped or U shaped here. A device is connected with a semi-enclosed chamber of dielectric materials. So performance of the oil circuit breakers is depending upon this arc control device. So this is the new idea in the bulk oil circuit breakers. Let us see this picture here. You can observe here whatever the gas produced, because of this narrow region, high pressure can be created so that arc can be quenched quickly. But remaining process is same, only some area of gas production is reduced such that pressure of the gas produced can be increased. So that is the only advancement in this. So this is the explanation given for the operation of this entire circuit breaker. So this is the operating rod 7, which is raised or lowered for operating mechanism. Contact separate, arc is drawn. Arc control devices are normally connected to the fixed contact assembly. This is the fixed contact assembly. This is the mobile contact assembly. So the gas produced in the device 4, it is the device 4, has high pressure in it. Thereby arc extension is quick. So that is the mechanism is there. As the moving contacts leave the arc control devices, normally they are in closed position. As they are moving like this, then what happens? The trapped gases, whatever the trapped gases, gets released from the arc control device. By doing so, arc is extinguished by blast effect. So arc control devices are fitted to all modern circuit breakers rated at 3.6 kV and above. The construction and venting of arc control devices such that gases flow axially. Axially means in the direction of the arc, radially, both the directions. This gas can be produced. And that means applied onto the arc. So these about arc control device, connect to the fixed contact. That's what I have discussed. Gases produced will produce inside the device, have high pressure in it. Arc extension is quick. So for voltage more than 3.6 kV, these are used generally. So axial venting, radial venting. As I said, gases producers sweep the arc in the longitudinal direction. So high pressure gas, high dielectric strength. Radial venting, sweep the arc in the transverse direction, used for relatively heavy currents. You see, axial venting is used for low currents at high voltages. Radial venting is used for heavy currents at low voltages. So sometimes combination of both is required for better arc extinction process. So what are the major disadvantages of this bulk oil circuit breaker? Large quantity of oil is necessary. Okay, because normally for arc extinction, small quantity is enough, but in this large quantity is required. So it is to provide insulation between the live parts and earthed steel tank. For all these things, large quantity is required. But normally, very less quantity of oil is enough for arc quenching. Entire oil in the tank is likely to get deteriorated. Therefore, sludge formation, carbon particle formation, that you have to remove to improve the dielectric strength of the oil. So these are all required. So tanks are too big because we have to accommodate the more amount of the water. Tanks are too big, tanks are required. These causes led to the development of the minimum oil circuit breakers. So less oil or minimum oil circuit breakers, that thought is because of this requirement of the more amount of the oil as well as quick arc quenching requirement. Because here there is no special mechanism. There some special mechanism will be there to speed up the arc quenching process. So arc extension medium is dielectric oil, same as that of the used in the tank type. There is no steel tank in the minimum oil circuit breaker, but arc extension takes place in a porcelain containers. Let us see that. So arc control in the circuit breakers is by two types of techniques: self blast, forced blast. What is self blast? Control is provided by internal means. Okay, what is forced blast? By separate mechanism. Arc control is provided by mechanical means. So by using these two techniques, arc control in the breakers can be done and arc quenching can be speed up. So this is the minimum oil circuit breaker. So is an important one. You can observe whatever the parts here. Here one, you can see here, keenly observe, it is a fixed contact. You can see the shape, arc control device shape. This is a fixed contact. Next, this is the moving contact, where just you can imagine injection. There is a needle. Needle has a hole. If you press the injection like this, the whatever the thing is there injection, that will come with high speed. That means by pressing in this direction, in the opposite direction, the water or whatever it may be inside, that will go out. So that is the moving contact here, which is connected to lower. 7 is the lower fixed contact here. So here one by one, if you see, 3 is the arc interruption chamber. This is outside, porcelain arc interruption chamber. And 4 is supporting chamber. Okay, 4 is the supporting chamber. Where is the 4? This is the 4 supporting chamber. There are two chambers, upper chamber, lower chamber. Okay, so upper chamber is current interruption chamber, lower chamber is arc interruption, lower chamber is supporting chamber, and fifth one is top chamber. This is the part where the gases. Next, sixth one is arc extension device. Here, this is the arc extension device. As I said, arc control device. Seventh one is lower fixed contact. As I said, eighth one is gas fiber enclosure. So here, this is the gas fiber enclosure. You see, this is the porcelain enclosure. This is gas fiber enclosure. This part. Next, ninth one is operating rod. So by moving this one downward, so if you move it like this by mechanism, this contact will move downward. So that is the process. So 10 is drain valve. Drain valve means if you want to take the oil sample or if you want to remove the anything, you can use this. Next, 11 is terminals. Here the conductor enters, here the conductor leaves. 12 is relief valve, where from gases can be taken out. And 13 is gas vent, where from extra gases can be taken out. So 14th is the operating mechanism. where this is the entire thing is operating mechanism. So now let us see. We have understood the each and every part of this. The simple thing is when the contacts are separated, then what happens? Arc is produced inside. Then because of this shape, the pressure of the hydrogen gas is increased. At the same time, when it is moving downward, then it is the just like injection, the pressure of the oil is increased, so that oil with high pressure, jet, just like a jet, it will be pumped through the moving contact. It is pumped through the moving contact like this. So because of this, what happens? The arc extension will be quick. One is hydrogen gas is produced that will punch the arc, reduce the diameter. Another one is oil with high pressure, just like injection, high pressure, it will be pumped onto the arc so that arc extension will be quick. So this is the operation inside this. So you can see all the things given in this picture: 2 chambers, 3, 4, upper chamber, extension chamber, lower chamber is supporting chamber, 6 is arc extension device, 7 fixed contact. Here, so resin bonded glass fiber 8. This is the one to observe this. What is the process inside? The cylinder 8 also filled with oil, and 3 is porcelain enclosure. This all the explanation is given about the construction and the various parts. Coming to this in-oil circuit breaker, only 10% of the total oil required for the bulk oil is enough, because very less amount of oil is required for quenching the arc. So tank size is reduced and weight of the breaker also reduced. So MOCB employs solid materials for insulation purposes with a small quantity of the oil. Suitable arc control devices, by using that, extension can be further facilitated. There is no steel tank requirement. Arc extension takes place inside the porcelain container. So in the construction point of, I told already, upper chamber is a circuit breaking chamber, lower chamber is a supporting chamber, and the lower chamber, the supporting chamber, what it contains is mounted on the metal chamber. It is filled with oil. What is physically separated from the oil in the circuit breaking chamber? These two are separated from each other. You have seen in the first slide, there are two positions, how to, the different chambers are there, the practical picture. So this is circuit breaking chamber, this is the supporting chamber. It acts like a dielectric support. That means to pump the oil after reducing the diameter of the arc. So I have given clear explanation about the arc extension chamber. Moving contact. Moving contact is having halo. Halo. It is a halo contact. It includes a cylinder which moves down over a fixed piston. It moves like this. While moving with high pressure, the oil is pumped onto the arc. Axial venting ensures the inversion of the low currents. Radial venting ensures heavy currents. The top chamber is a circuit breaking chamber. So here is the operation of the circuit. Under normal conditions, moving contact remains engaged with upper fixed contact. When a fault occurs, moving contact is pulled down by tripping springs nor struck. The arc energy vaporizes the oil and produces gases under high pressure. This action constrains the oil to pass through the hole, central hole here in the moving contact, and results in forcing. The process of tabulation is the orderly one, in which selection of the arc is successfully quenched by the effect of separate streams of oil moving across. So whatever the oil required to clear this arc, that will be pumped through this nozzle. So here you can see the practical picture of a oil circuit breaker which has two chambers like this, which are mounted on a insulating structure. This is the one you can observe, where this is the upper chamber, this is the lower chamber. So these are the contacts. So principle of arc extension in the oil circuit chamber, if you see, when the arc is struck here, then you can see These all depends upon the design of the arc control device, this device. So the high pressure is created inside, and that high pressure will lead to the quick arc punching. So the pressure buildup depends upon the arc control device, speed of the contact travel, how speed it travels, energy liberated by the arc. So these are all the means to clear the arc quickly. Arc control devices are fitted to the fixed contact of the minimum oil circuit breaker. So here you can see in this picture, arc control devices modify the behavior of the arc punching. So dielectric material fitted to the contacts of circuit breaker such that actual contacts are separated inside the cavity. This is the cavity you can see. There the separation takes place. At current zero of the wave, arc diameter is very small. At current zero, you know, because current zero interruption I have explained, gas flow is able to interrupt the arc. Interruption of the arc stops the generation of the gas and flow of oil. Once the arc is interrupted, what happens? The gases, hydrogen gas production will be stopped. Then at that instant, what you have to do? You have to stop the arc restriking again. That means that entire gap should be filled with oil. That is important. That means at the time of the arc, hydrogen gas is produced. Once the arc is cleared for brief moment, the gases formation will be stopped at current zero. Then at that moment, oil should be forced. Oil has to occupy that place with high force. So that is the principle behind this. Therefore, contact space contains hot gases during the brief period after the interruption of the arc. High rate of rise of restriking voltage TRV will be there, which will cause the restrike. To avoid this, contact travel is extended well beyond, and the arc control device, fresh dielectric coil is pumped onto the contact space. That's what we have done in the minimum oil circuit breaker. So this is the process we have explained. From this, we will push the oil onto the contact space, flushing the contact space by dielectric coil forced into the contact space by means of piston action. So that is the one way to clear the arc quickly to improve the dielectric strength of the current zero. Another is maintaining pressure on the oil in the interrupter by inert gas. By using these two techniques, we can punch the arc quickly after current zero. So sensitive to TRV, that's what I said. In plain brake oil circuit breaker, you see, so it requires less quantity of oil, smaller space, reduced risk of fire, maintenance problems are reduced in the minimum oil circuit breakers. Smaller quantity of oil, degree of carbonization is less increased, and dielectric strength of the oil deteriorates rapidly due to high degree of carbonization. Those things are there as disadvantages. These are the various ratings of the breakers, various ranges that can be used.